Okay, so this is the key to worksheet 3.1 part 3. Now in this worksheet you're looking at still quadratic functions, but these quadratic functions are written in general form. They're not written in standard form or vertex form, they're written in general form. So you have number 1 that's in general form, and you also have number 2 that's also in general form. Now remember, when it's in general form, you have to use the vertex formula. And once you find the vertex, then everything else falls into place. Okay, so remember when you have a quadratic function in general form, the vertex formula is this. So you use this as a vertex formula. So remember, the vertex is a point. So we're going to call that HK, just like we did in standard form. Now h is going to be negative b divided by 2a. So the opposite of b divided by 2a. So that's going to be the x-coordinate of the vertex. So that's h, the x-coordinate of the vertex. So remember, once you find the x-coordinate, to find the y-coordinate, you're going to say, you're going to evaluate f of negative b over 2a. So in place of x, you're going to plug in negative b over 2a. All right, and so that's going to give you your vertex. Now, what you may want to do first is denote what A, B, and C are, just like you did when you solved a quadratic equation. Now, this is going to be important. This A, B, and C are going to be important when you find the x-intercepts. All right, so A is a coefficient of x squared, so that's 2. B is a coefficient of x, so that's 8. And C is the constant, so that's negative 5. All right, and so the vertex, so negative b divided by 2a, that's h, or the x-coordinate of the vertex, is the opposite of b. So b is 8, the opposite of 8 is negative 8, over 2 times a is 2, so that's negative 8 divided by 4, which is negative 2. So your x-coordinate of the vertex is negative 2. Now to find the y-coordinate, you're going to find f of negative 2. So in place of x here, you're going to plug in negative 2. So I can get f of negative 2 is 2 times negative 2 squared plus 8 times negative 2 minus 5. So negative 2 squared is 4. 4 times 2 is 8. 8 times negative 2 is negative 16 minus 5. So that's a negative 8 minus 5, which is a negative 12. Oops, sorry. Okay, negative 13. So I get the vertex negative 2, negative 13. Okay? Now, the domain, remember the domain of all quadratic functions is going to be all real numbers. So every point, remember every point on a quadratic function on a graph, so if this is your plane, and let's say this is your parabola right here, and as you go from left to right along your x-axis, every point on this x-axis, every x value is going to represent a point on this graph. So if x is, let's say, positive 1 million, I am going to get a point on the graph. Okay, if x is 2 million, I'm going to get a point on the graph. I'm going to get a y-coordinate. If x is this x value here, I'm going to get a point on the graph. So I'm going to get some y-coordinate. Okay? So as you go from left to right, the domain's all real numbers. So you can say negative infinity to infinity. Now the range, you can determine without doing this part yet. So all you got to do is look at a rough sketch of this. Okay, so listen carefully, and it's very similar to the previous one. So the vertex is negative 2, negative 13. So that's in the third quadrant. The coefficient of x squared, a, is 2. Since a is positive, the parabola opens up. And so the range then, you're going to go from along the y-axis from bottom up. So I start touching the graph at the vertex. So this vertex right here is negative 2, negative 13. So remember, you're looking at your y coordinates, you're looking at your y values, so you're going to use this. So you're going to say the range is from bracket -13 to infinity, so -13 all the way to infinity. All right, let's talk about the y-intercept. The y-intercept, you're going to let x equal 0. Now this one's easier to deal with because it's in general form. And what you got to notice is that whenever it's in general form, your y-intercept is just a constant, because the x squared term, when you replace x with 0, that's just 0. A times 0 is just 0, so you're left with your constant. So your y-intercept is always going to be c. So in this case, it's -5. All right, now the x-intercepts are going to do a little bit more work. To find the x-intercepts, you're going to let y equals 0. Now remember, f of x is y, right here. So you're going to set this equals 0. So 2x squared plus 8x minus 5 equals 0. Now notice that from chapter 1 in a previous lesson, this is a quadratic equation. So you have to solve this quadratic equation. So not all quadratic equations are factorable, so just use the quadratic formula. So remember, the quadratic formula is this. This is quadratic formula. So the quadratic formula is, so the x equals the opposite of b, plus or minus the square root of b squared, minus 4ac, whole over 2a. That's your quadratic formula. You used this in a previous lesson. So again, this is your a, this is your b, this is your c. So let's plug these values into this quadratic formula. So I get x equal the opposite, remember this says the opposite of b. So if b is 8, the opposite of 8 is -8. Plus or minus the square root of b squared, so that's 8 squared, minus 4 times a is 2, times c, which is -5, all over 2 times a, which is 2. So that's a 2. 2 times 2. And so that becomes -8 plus or minus the square root of 8 squared, 64. A -4 times 2 times a -5, that's a positive 40, all over 2 times 2 is 4. So I get -8 plus or minus the square root of 104 divided by 4. Okay, now 104 is not a perfect square, and all I'm interested in is the approximation of these x-intercepts. So just leave it like this. Don't simplify the radical. Just leave it like this. Just use your calculator, though. So you're going to do the numerator first. So you're going to say -8 plus the square root of 104. Close the parentheses, now press equal. So what you found here was the numerator. So that's just the numerator, but you got to press equal to get that numerator. Then you divide that numerator by 4. So as you get that answer is your numerator. And my x-intercept to the nearest tenth is about 0.5. So one of them is 0.5. That's one of them. Okay, let's do the other one. So the other one, you're going to say -8 minus, this time, the square root of 104. Close the parentheses, press equal, and what you found was the numerator this time. Divide by 4, and the other x-intercept is -4.5. So that's your other one. Okay? All right, now let's go ahead and graph these. So we're gonna plot the vertex. So -2, -13. So -2, -13 is about here. So that's -2, -13. The y-intercept is -5, so that's about here. And the x-intercepts, one of them is 0.5. Oh, and let's just go ahead right now and just label the axis of symmetry. Alright, so here's 0.5 right here, and then -4.5 is about here. Just make sure that these x-intercepts, they're the same distance away from the axis of symmetry. So this kind of looks right. So this distance looks like this distance. There's these points are supposed to be symmetrical about the axis of symmetry. So you have 4 points. You have the vertex, you have the y-intercept, and you have these two x-intercepts. Okay, you need one more point because the direction says 5 points. Well, use the y-intercept. So the y-intercept is 2 units from the axis of symmetry, so go 2 units this way. So just reflect it about the axis of symmetry. So here's your point, and then all you got to do now is just graph. Now do the best you can with graph. Make sure it looks like a curve though. Do not use segments. Get something that looks like that. Okay, so that was number 1. Okay, so number 2, again, you're looking at general form. This time A is -3, B is -6. Now make sure you're labeling these correct. So A is -3, B is a coefficient of x, that's -6, and C is 4. Alright, so let's find the vertex. So the vertex, the x-coordinate of your vertex, which is h, is going to be -b over 2a. Now when I say h, remember the vertex is labeled as hk, so h is your x-coordinate. Alright, so this says take the opposite of b, so b is -6, the opposite of -6 is 6, over 2 times a is -3, so that's 6 divided by -6, which is -1. So the x-coordinate of my vertex is -1. Alright, now we got to find the y-coordinate. So once I find the x-coordinate, I just plug that back into here to find the y-coordinate. So remember, now we got to find f of -1. So f of -1 then would be -3 times -1 squared minus 6 times -1 plus 4. And so -1 squared is 1. 1 times -3 is -3. A -6 times a -1 is a positive 6, and then plus 4. So this is 3. -3 plus 6 is 3, plus 4, which is 7. So my vertex is -1, 7. That's your vertex. So right here, -1, 7 is your vertex. Alright, the domain, remember the domain, this is a quadratic function, so the domain is going to be all real numbers, always. Alright, now the range. So the range, let's kind of do a rough sketch of this. So my, oops, I said -1, 7. -1, 7, excuse me, is here. So -1, 7 is in the second quadrant. -1, 7 is in the second quadrant. And let's determine whether the parabola opens up or down. So remember, A here is -3. A is -3. So A determines whether the parabola opens up or down. So since A equals -3, which is negative, the parabola opens down. Alright, so the parabola opens down. Okay, now, so it's going to do this. So you are going to have x-intercepts. You are going to have x-intercepts. So that we know. So we got to figure this out at some point, just like we did in the previous problem. Okay, now, okay, so the range. So since we know what the rough sketch looks like, and we see these arrows are pointing down, so you're going from -infinity all the way to this maximum y value, so this maximum point. So this is the point -1, 7, so the maximum y value is 7. So the range will be from -infinity to 7 with a bracket. Okay. Now the y-intercept, remember this is general form, so the y-intercept, just remember let x equal 0. So this one's easy to do. Let x equal 0. This is 0 because x squared, 0 squared is 0. 6 times 0 is 0. Now you're left with your constant. So remember, we said the y-intercept is always going to be the constant as long as it's in general form. Okay, it has to be in general form. So remember when we did this though. See this right here? That's not general form. So don't make the mistake and say the y-intercept is -9. That's not true. So remember, for the y-intercept here, when it's in standard form, you have to do some work. Here, though, there's really no work to do. If you let x equal 0, that's 0, that's 0, and you're left with 4. So the y-intercept is just 4. Okay, now let's find the x-intercepts. To find the x-intercepts, you're going to let y equal 0, so that's f of x. And so when let y equal 0, I get this equation right here, or this right hand side, negative 3x squared minus 6x plus 4, and I got to set that equal to 0. All right, and then we just use quadratic formula. So remember the quadratic formula is this. This is quadratic formula. So quadratic formula, remember the quadratic formula. So it's the opposite of b plus or minus the square root of b squared minus 4ac all over. So make sure you say all divided by 2a. So all this has to be divided by 2a. All right, so I get x equal. Now remember, we're talking about x-intercepts now. So that's what we're finding, the x-intercepts. But this is a quadratic equation. So I got to solve this equation. We're going to solve it using the quadratic formula. All right, so according to quadratic formula, this says I take the opposite of b. Well, b is negative 6, so b is negative 6. This becomes a positive 6. Plus or minus the square root of negative 6 squared, b squared, minus 4 times a. A is negative 3, times c, which is a positive 4. All divided by 2 times a, so that's 2 times negative 3. And so, simplifying the radicand, I get 6 plus or minus the square root of negative 6 squared is positive 36. A negative 4 times the negative 3 times a positive 4 is a positive 48 divided by 2 times negative 3 is a negative 6. So it becomes 6 plus or minus the square root of 36 plus 48 is 84. Okay, all divided by negative 6. Now, since 84 is not a perfect square, don't worry about simplifying this. You're not interested in simplifying this here. You just want to know what are these x-intercepts approximately equal to. That's what you want to know, so that way you can plot these points. All right, so we can use your calculator. So you're going to say 6, just like you did here. So you're going to say 6 plus the square root of 84, close the parentheses, and when you press equal, that gives you a numerator. That's just a numerator of 6 plus the square root of 84. Now you got to divide by negative 6, and, oops. All right, so divide by negative 6, and you get approximately negative 2.5. So that's one of them. Okay, the other one, you're going to say 6 minus the square root of 84, close the parentheses, press equal so you can find the numerator. When I find the numerator, that's then divided by negative 6. That's going to give me 0.5. Okay, so those are your two x-intercepts. All right, so let's go ahead and plot our points that we know of. So negative 1, 7 is the vertex, so that's going to be in the second quadrant, negative 1, 7. The y-intercept is 4, so I'm going to cross the y-axis at 4 right here. Let's go ahead and draw the axis of symmetry. Okay, the x-intercepts are negative 2.5 and 0.5, so 0.5 is here, negative 2.5 is here, and just kind of make sure that these intercepts are the same distance from the axis of symmetry, so they kind of look symmetrical. All right, and you just need one more, and that one more we're going to use the y-intercept. So this is 1 unit to the right, then this has to be 1 unit to the left. And so you just graph and you're done. You're done. Just do the best you can with graphing, that parabola. Just make sure it looks like a parabola. And that's it. So there's the graph of number 2. So remember, in this worksheet though, these were in general form, so you had to use the vertex formula to do that. And also remember, in the x-intercepts, you had to use the quadratic formula to do that. Whereas before, when it was in vertex form or standard form, to find the x-intercepts, I had to use the square root property. So make sure you see the differences between these two. Okay, so the general form, to find the x-intercept, you use the quadratic formula. If it's in standard form, you're going to use this at some point. You can use the square root property. In general form, the vertex, you have to use the vertex formula, so there's a little bit more work. Whereas in standard form, the vertex, you just read off from the vertex formula. So this is in that form, so it's easy to find. The vertex is quick to find here. There's a little bit more work here. Okay, so make sure you look at the differences between part 3 and part 2.